Ladies and gentlemen, stargazers and seekers, welcome back to another late-night journey through the mysteries of our universe. This is the Midnight Museum, where we open doors to the strange, the curious, and the cosmic. Tonight, have you heard? There's a visitor in our cosmic neighborhood, a traveler from another star. Some say it could even be alien technology. We're going to unpack the headlines and the history behind interstellar objects. What's real, what's speculation, and why these wandering bodies matter. So grab your favorite mug, settle in, and join me as we explore the facts and the fiction.
Thanks for having me. It's always a thrill to be here. Nothing beats discussing space at midnight under a sky full of stars.
Absolutely. And tonight is special. Just a few weeks ago, astronomers announced the discovery of a comet named 3I/ATLAS. In plain terms, it's an object that didn't form in our solar system. It was born around another star and somehow got knocked loose, sent on a hyperbolic trajectory that brought it near us. And almost immediately, headlines were screaming about alien probes and secret messages. As someone who spends his days with telescopes and equations, what was your first reaction when you saw the news?
My inbox exploded. Friends were sending me articles with titles like, "Is this comet an alien ship?" It was amusing, but it also reflects just how fascinated people are by the idea that we might not be alone.
The words interstellar and alien press all the right buttons in our collective imagination. Tonight, we're going to sift through the data, look at the science, and also revisit past interstellar visitors. We'll see where speculation runs wild and where curiosity leads to genuine discovery. Ready to take our listeners on that ride?
Absolutely. Let's dive in.
Let's start with the newcomer itself. 3I/Atlas was spotted on July 1st, 2025 by the Asteroid Terrestrial Impact Last Alert System in Chile. It's called 3I because it's only the third interstellar object ever confirmed. When scientists traced its path backwards, they saw it wasn't looping around the sun, but instead traveling on a hyperbolic trajectory, basically a one-way ticket through our neighborhood. How do astronomers decide so quickly that an object is from outside the solar system?
Great question. It all comes down to the object's orbit. Most comets and asteroids move around the sun in elliptical orbits. They're bound by our star's gravity. When you plot their paths, you can see them circle back around. But a hyperbolic orbit is open-ended. The object speeds in, whips around the sun, and flies back out, never to return. You also calculate the object's velocity. 3I/Atlas is moving at about 245,000 kilometers per hour, far faster than typical comets. Combine that speed with the shape of its trajectory, and you have clear evidence it's not from here.
Fast is an understatement. It's the fastest object we've ever seen in our solar system. Early estimates put its size at up to 20 kilometers across, though it could be smaller according to later Hubble measurements. What else do we know about it so far?
Not as much as we'd like. It appears to have a dusty coma, the cloud of gas and dust that gives comets their fuzzy appearance. Hubble images show a teardrop-shaped cocoon of dust around its nucleus. That dust cloud is a strong sign that it's a comet, not an asteroid, because its volatile materials, ices and dust, sublimating as it gets closer to the sun. We also know it's not going to hit us. Its closest approach to Earth will be around 170 million miles, well beyond Mars's orbit.
That's reassuring. So why did the alien probe idea even come up?
Enter Avi Loeb. He's a Harvard astronomer known for provocative ideas. Shortly after the discovery, he posted a paper asking whether 3I/ATLAS could be alien technology. He pointed out that its orbit would take it unusually close to Venus, Mars, and Jupiter, and that it appears to have some odd features. Loeb and his collaborators speculated about the possibility of it being a spacecraft. Media outlets ran with that. Suddenly, people thought NASA had found an alien ship. In truth, Loeb himself acknowledged that the simplest explanation is that it's a natural comet, but the story captured imaginations.
Aliens sell newspapers, or clicks, and yet NASA scientists responded pretty quickly. Tom Statler, NASA's lead scientist for solar system small bodies, said, and I quote, "It looks like a comet. It does comet things. It very strongly resembles the comets that we know." He noted that while 3I/Atlas has some unusual properties, those are within the range of what comets can do. So far, there's no evidence it's anything but a natural object.
Exactly. We should approach extraordinary claims with extraordinary evidence. At this point, all data points to a comet. Still, the excitement is understandable. It's only the third time we've had such an object pass by. It naturally prompts questions.
And that's where the probe versus pebble debate comes in. Before we get into conspiracies, though, let's rewind. This isn't the first time we've dealt with interstellar visitors. Let's go back to 2017, a year some of our listeners might remember for more than just earthly events. It's when scientists spotted the first confirmed interstellar object, Oumuamua. That word is Hawaiian. It means scout or messenger from afar. Why did Oumuamua stir up so much controversy?
Oumuamua was a game changer. For decades, astronomers suspected interstellar objects were out there, but we'd never seen one. When Oumuamua appeared, it defied expectations. Its shape seemed elongated, like a cigar or pancake, and it didn't have the clear cometary coma we expected. Observations showed it was tumbling end over end and accelerating slightly, in a way that wasn't entirely explained by gravity alone. Some researchers suggested the acceleration was due to outgassing, jets of gas pushing it along. Others, including Avi Loeb, proposed that it might be thin and flat, like a solar sail engineered by alien beings.
And so began the first round of, could it be an alien probe?
Exactly. The debate about Oumuamua lasted for years. Most mainstream scientists favor the explanation that it was an oddly shaped, icy fragment of a larger body. The non-gravitational acceleration could be due to outgassing that was too subtle to detect visually. Maybe the object released hydrogen from long-term cosmic irradiation. But because of the limited data and our inability to revisit it, some questions remain. Oumuamua taught us that interstellar objects can have surprising properties that stretch our models.
It also demonstrated how a single, unusual observation can spur a wave of speculation. In fairness, the idea of an alien craft is not totally unreasonable. After all, humanity has already sent Voyager and Pioneer probes out of the solar system, but the burden of proof is heavy.
Exactly. The difference is that with Oumuamua, we had extremely limited time. It was discovered after it had already passed its closest approach to the sun. And by the time scientists realized how odd it was already fading away. That fueled speculation, but left little opportunity for follow-up observations.
And yet, it inspired research programs dedicated to catching these things earlier. We'll see that when we talk about Atlas and future surveys. 2 years later, in 2019, the second interstellar object, 2I/Borisov, appeared. It was discovered by an amateur astronomer, Comet Borisov, using a homemade telescope. This one didn't inspire nearly as many conspiracy theories. Why?
Because Borisov looked like what we expected. It had a beautiful coma and tail, just like an ordinary comet. Its chemical composition, examined via spectroscopy, showed it was rich in carbon monoxide, more so than typical solar system comets. That in itself was fascinating because it hinted at conditions in a different protoplanetary disk. But there was nothing to suggest it was anything other than a chunk of ice and dust. The lack of anomalies made it less of a lightning rod for alien speculation.
And yet, scientifically, it was just as exciting.
Absolutely. Borisov confirmed that interstellar objects are not unique. Our solar system is permeable. It gave us a chance to study material from another star system up close. We learned about its volatile contents, its structure, and even its dust grains. It broadened our understanding of what other solar systems might look like. The fact that Borisov didn't trigger as much media hype shows how sensationalism often drives public attention. Science itself was thrilled.
Let's unpack how we find these cosmic drifters. Catching a fast-moving, faint object across the backdrop of space seems like finding a specific ripple in an ocean. How did telescopes like ATLAS and the Zwicky Transient Facility find 3I/ATLAS?
Sky surveys play a huge role. ATLAS stands for Asteroid, Terrestrial Impact, Last Alert System. Its primary job is to spot potentially hazardous asteroids, but its wide-field cameras also pick up comets and other transients. It scans the sky nightly and uses software to detect moving objects. When ATLAS recorded 3I/ATLAS, the orbit calculations immediately jumped out as odd. The Minor Planet Center collects these observations and computes the orbital elements. Once the hyperbolic orbit was clear, astronomers around the world turned their instruments toward the newcomer. Meanwhile, the Zwicky Transient Facility at Palomar Observatory also looked back through its data and found pre-discovery images, confirming the trajectory.
Modern sky surveys are like cosmic security cameras, always recording. The difference between now and 2017 is that we had more coverage. That's why we could spot 3I/ATLAS earlier and follow it for longer.
Exactly. Future surveys like the Vera C. Rubin Observatory's Legacy Survey of Space and Time will go even further. LSST will scan the entire visible sky every few nights with a 3.2 gigapixel camera. That kind of cadence will detect more interstellar interlopers, giving us time to characterize them thoroughly.
So the next time one comes by, we might even send a spacecraft to intercept it.
That's the dream. There's been talk of a mission concept called the Interstellar Probe that could launch and rendezvous with an incoming object. Catching something moving that fast would be challenging, but having early warning from surveys makes it feasible.
Let's zoom out. Beyond the fun of spotting rare visitors and debunking conspiracies, why do scientists care about these objects?
Interstellar objects are messengers. Each one is a piece of another solar system's building blocks. Imagine being able to study a rock from a star system we'll never visit. You can learn about the chemistry, the dust, the ices that existed around a different star, perhaps billions of years ago. That tells us how common water is, how planets form, and maybe even how life might arise. Borisov's carbon monoxide content suggested it formed in a very cold region of its home system. If we find an object rich in ammonia or methane, that tells a different story. And there's also the philosophical side. These objects remind us that we are not isolated. Our solar system exchanges material with the broader galaxy.
There's also the question of panspermia, the idea that life, or at least the building blocks of life, can travel between star systems on rocks like these.
That's a tantalizing possibility. We don't have evidence yet that microorganisms survive interstellar space, but the idea that interstellar debris could seed life somewhere else is fascinating. It ties into the story of how life began on Earth and whether it could begin elsewhere. Studying these objects might provide clues.
So, beyond the headlines, interstellar comets are scientific gold mines. And the more we find, the better we'll understand our place in the cosmos. Let's circle back to conspiracies for a moment. Why do you think the idea of alien probes traveling on comets captures people's imaginations so strongly?
Humans are storytellers. For millennia, we've looked up at the sky and woven myths about what we see. Comets were once omens of disaster or heralds of change. In a modern context, with science fiction and our growing understanding of the universe, it's natural for people to imagine that mysterious objects could be alien craft. It speaks to our desire to know whether we are alone. Plus, media tends to amplify extraordinary claims because they draw attention. Nuance sometimes gets lost.
There's also a mistrust of institutions. Some people assume that if NASA says it's just a comet, they're covering up the truth.
Yes, and that's a challenge for scientists. We have to communicate clearly and transparently. When Tom Statler said, "It looks like a comet. It does comet things," he wasn't trying to squash curiosity. He was grounding the conversation in data, but some will always suspect a hidden agenda. It's important to encourage healthy skepticism without sliding into baseless conspiracy.
That skepticism can be productive when it pushes us to ask hard questions and gather more evidence, but it becomes harmful when it dismisses facts in favor of sensationalism.
Precisely. The best approach is to be curious, check sources, and understand that extraordinary claims require extraordinary evidence. So far, stellar comets have given us incredible science without any sign of alien technology.
Science fiction has long imagined interstellar travelers, not just comets, but spacecraft. Arthur C. Clarke's Rendezvous with Rama starts with humanity discovering a cylindrical object passing through the solar system. When it turned out to be an alien starship, adventure ensued. Do you think fiction influences how we perceive real phenomena like 3I/Atlas?
Absolutely. Fiction inspires us. It primes our imagination to interpret ambiguous signals in certain ways. When Oumuamua showed up, many people drew parallels to Rama. Similarly, the concept of an alien probe disguised as a comet comes straight out of science fiction tropes. That's not a bad thing. Fiction encourages exploration, but we must separate narrative from evidence. Science often reveals stories stranger than fiction anyway.
Also, look at the Voyager probes. Each carries a golden record with sounds and images of Earth. We launched them in the 1970s, and they have now left our solar system. In a way, they are our own interstellar messages.
And that brings us full circle. If we assume other civilizations exist, it's plausible they might send probes too. But the difference is that we've announced ours. If aliens were passing by disguised as comets, they'd be deliberately hiding. That raises philosophical questions about motives and detection. Fun to think about, but speculation nonetheless.
Let's look at other times when cosmic phenomena sparked conspiracy theories. Remember Comet Hale-Bopp in 1997?
I do. Hale-Bopp was a spectacular comet visible to the naked eye for months. It coincided with the rise of the internet. A fringe group, the Heaven's Gate cult, became convinced that a spaceship was trailing the comet. They believed that by leaving their physical bodies, they could board this imaginary spacecraft. Tragically, this led to it was a stark example of how conspiratorial thinking can have real, devastating consequences.
Then there was the Nibiru, or Planet X myth that keeps resurfacing. People claimed a hidden planet would collide with Earth. NASA repeatedly debunked it. Yet the idea persists because it's compelling to some. The promise of secret knowledge makes people feel empowered.
Exactly. When dealing with space, there is often a gap between what scientists know and what the public hears. If that gap is filled with misinformation, conspiracies thrive. That's why it's vital to communicate science clearly, to share the wonder without letting fear take over.
And it's why shows like this exist, to blend storytelling with evidence. Looking ahead, what do you think the next decade holds for the study of interstellar objects?
We're on the cusp of an observational revolution. As I mentioned, the Vera C. Rubin Observatory will dramatically increase the number of transient objects we detect. We expect to find dozens of interstellar visitors per year, rather than one every few years. That means we can categorize them, look for patterns, and maybe even identify classes of objects we haven't imagined.
Will we be able to launch missions to them?
I think so. There's the Comet Interceptor mission planned by ESA to visit a pristine comet. NASA and other agencies are exploring fast launch concepts. If you have just a year or two of notice, you can send a small spacecraft to intercept a fast-moving object. It requires innovative propulsion and mission design, but it's within reach. If we could send a probe to an interstellar object, we'd be doing on-site geology of another solar system. Imagine what we could learn.
And what about advanced telescopes?
James Webb, Hubble, and upcoming instruments like the Roman Space Telescope will continue to observe these visitors from afar. Spectroscopy will reveal their composition in detail. Combined with laboratory studies of meteorites and simulations of planet formation, we'll build a more comprehensive picture of how planetary systems form and evolve.
So we come back to 3I/Atlas. It's not an alien spaceship. At least there's no evidence for that. But its very existence is extraordinary. It's a fragment of another star system sailing through ours. It reminds us that the galaxy is not a collection of isolated islands. It's an ocean with currents of ice and rock flowing between the stars. Each interstellar visitor carries a piece of its home, a chemical signature etched over billions of years.
And whether it's 3I/Atlas or Oumuamua or Borisov, these objects teach us humility. Our models are good, but the universe is endlessly creative. We get to be detectives, piecing together clues about places we may never see. And we must be careful not to let our desire for wonder turn into credulousness. Speculation is fun, but evidence is everything.
As for conspiracies, they tell us something too. They reveal our yearnings for connection, for meaning, for the extraordinary. When confronted with the unknown, we can choose to embrace curiosity and seek knowledge, or we can retreat into fear and fiction. The choice is ours.
And the more we learn, the richer the real story becomes.